One of the challenges of 3D modeling and rendering is that it's very processor intensive. We have discovered in past semesters that when people are working at home, often a subset of students have issues with their computers not being able to handle the graphics. I'm assuming that most of you are going to be working at home this semester. Most students attempt at least to work at home in regular semesters. So certainly this semester, I'm going to assume that most of you are working at home. So I've developed this little test so we can find out now before the semester starts if anyone is going to have problems with their hardware, so that hopefully we can find a way to address it. I have run this test on all of the, well, not all of, but one of the computers in the computer lab. They're all the same, and it does work on those computers. So if you are able to use the computer lab, I'm putting in air quotes here, guarantee that the software will run accurately on those computers. But so let's give this a try. I'm just going to open this file. I have download the file obviously from the email, and then open it by either double clicking on it if you don't have the program open, or if the program is open, you can just use File, Open, and find the file wherever you downloaded it. Your overall screen setup may look a little different than mine, but hopefully you see the major element here, which is this model. This is an environment that I created just for this test. That's sort of a set for the 3D Modeling Awards show or something. But I put it together for some specific reasons. It has some curved surfaces. It has a complicated shape. It has some recessed neon lighting. So it has a shiny floor. Those are the sorts of things that tax the hardware. So in order to do this, you need just two things. You need the file open, and then you need to make sure that the object info palette is active. That's here. If you don't see something called object info, if you go to Window Palettes and make sure that the object info is checked, that's how you get the object info open. I know that many of you who took the Vectorworks class last semester know about this, but in case you're new to Vectorworks, the palettes are where all of the tools are, and for this particular test, we need object info. So after making sure that object info is on, if you go to the Layers menu, which is here, and click on it, you'll see that there are 3 sheet layers and a variety of design layers. We're going to look at the 3 sheet layers, which are different versions of the same model, or it's the same model with 3 different versions of the lighting, and let those compute to see if they work. So if you click on the first one, number 1, OpenGL, you should get what appears to be exactly the same view, only now it's a viewport. And we'll talk about what viewports are in class, but it's surrounded by this red and white stripe. Some people call this the candy cane stripe. If you click on the stripe, you'll see when I get close to the edge, close to the stripe itself, the overall rectangle turns orange. But if you click on the stripe itself, then the viewport will become active. Object info will become active and let you know that this is a viewport. And there will be a button here that says update that's red. Viewports have to be updated whenever a change is made in the document, in this case opening the document with the change. So if you just click update here and give it a moment or two, the image will render. So this lighting style is OpenGL, which is the sort of base level working lighting. Hopefully you're all able to get this one to render. This is the mode OpenGL that will be doing most of the work in. If this doesn't work for you, then we need to figure out a solution. The next two that we're going to look at are better lighting, but we can get through the class if we can't do the next two. If you can't get this one to work, then we need to figure something out. But hopefully that worked for all of you. So that's OpenGL. Then once that's complete, if you go to number 2, which is RenderWorks with no direct lighting, we get the same setup again. We're going to click on the red and white stripe to activate the viewport and click update. This one's going to take longer. This is more realistic lighting. OpenGL is sort of I like to think of it kind of as cartoon lighting. But number 2 and number 3 are using calculated lighting, which it uses a method called ray tracing, where it looks at the light source and actually computes the light ray going from the source of the light to where it hits on the object. So if it hits the floor or hits the wall or hits the person, it actually calculates that path that the lighting is taking, and each individual ray of light. And that's how we're able to simulate the shiny reflective floor or the accurate shadows, but it takes a lot longer and it takes more computing power for it to do the ray tracing than it does the OpenGL. So I'm just going to let this run in real time so you can see how long it could potentially take. I'm running this on a slightly less than a year old MacBook Pro. If you happen to have a PC non-Mac gaming laptop, yours may be running much faster than mine is. If you're running it on Windows Surface or something that's not really a high-powered computer, yours may be running much slower than mine is. So this should take about, on my machine, this usually takes about 2 minutes for this image to generate. When we get to actual videos in class, we'll speed them up when we are doing these things so that you don't have to wait. So that took 1 minute and 50 seconds. If you look down here in the corner and see how long it took. And if we look at the difference between that and this, you can see what I mean by this is kind of cartoon lighting, and this is more realistic lighting. It would be great if you're all able to render in this mode. But like I said, if you it's not horribly detrimental if this doesn't work, as long as this does. The final test, number 3, is the one that will tax your machine the most. So we'll try that and see who is able to do it. So go to number 3 here, the third sheet layer. Select the viewport and hit update. This one's going to take about twice as long as the second one. What this one is doing is not only calculating each individual ray of light as it leaves the light source and hits whatever surface it is hitting, but then it takes into account what that light does after that, which is bounce. So if you imagine there's a light source here, the ray of light leaves that light source, it hits the floor, it bounces off the floor and hits this wall, it bounces off this wall and hits that wall, it bounces off that wall and hits the floor again, and it just keeps bouncing around the room. You can set the program to calculate a number of bounces. Generally you can set it to calculate either no bounces, which is what sheet number 2 did, 3 bounces, 4 bounces, or 16 bounces. Once you get past 16, you start getting really diminished returns. It's really difficult to see the difference between 16 bounces and 32 bounces. So I went ahead and set this to 16 bounces, so it's the most taxing of the hardware, just so that we can get a good sense of whose computers are able to calculate this and whose aren't. And once again, I'm going to let this run in real time so you can sort of see what it looks like as it's rendering. But in addition to getting the bounce off the floor and the bounce off the white walls in this mode, you also start to see the effect of the modeled lighting in the floor and the lighting under the stairs, which you didn't really see in number 2, and you certainly didn't see in number 1, but you can see that this lighting is in fact actually lighting up the bottom of the wall, and the lighting under the stairs is in fact lighting the stairs under it. So this is the most realistic of all of the lighting effects, but it also is the most processor intensive and takes the longest amount of time. This is probably going to take about 3 minutes. I may have said that already. People often ask what the significance of the teapot is. No one's entirely sure that the teapot is actually the symbol for rendering in Vectorworks. The best any of us have been able to come up with is that it's slow enough that you can go make a pot of tea while you're waiting for it to render. This actually is really fast, comparatively speaking. To render this image 5 years ago would have taken twice as long. And when I was rendering in college in the mid-'80s, which is when Pixar had just sort of been founded, so this was all new back then, it would take, so that took 3 minutes and 15 seconds. In the mid-'80s, it would take overnight, sometimes up to a week, for an image like this to render. So 3 minutes is not so bad. So hopefully some of you are able to render this image, and if we look at the difference, we've got this is the most realistic, this is realistic but slightly less realistic, and then number one is you can see what's going on. It's not particularly realistic, but so let me know how this test turned out on your machine. Let me know, I was able to do number one, number two took forever, and number three crashed my machine, or I was able to do all three, or I wasn't able to do any of them, or I need help, this didn't work at all for me, whatever your experience was. If you'll write back and let me know, I'd appreciate it, so that I can hopefully make some plans for the semester. I look forward to starting class with you in a couple weeks, and thanks for playing along with the rendering test.